Welcome back my dear friends and dear students. A very good morning, good afternoon, good evening wherever you are, and welcome once again to this course of DADM, which is Data Analysis and Decision Making 2 under the NPTEL MOOC series. And as you know, this course is total duration is 12 weeks, which is 60 lectures, that is 30 hours, each class being for or lecture being for half an hour, and in a week we have 5 lectures. So, now as you can see from the slide, we are in the 26th lecture, which is the first lecture in the 6th week, and my name is Raghunandan Sengupta from the IME department, IIT Kanpur in India. So, if you remember, we are considering the concept of ELECTRE process, and I did mention very briefly though. So, there are 6 different methods for ELECTRE, but we will consider the simplest one. I did also mention that this is a multi-criteria decision making, where you make comparisons for decision based on alternatives, taking 2 at a time, and you rank them, and is almost similar to AHP method, where you give scores in the AHP method, but here you will basically find out 2 different criterias. One set is that how much you like a decision with respect to the other. If you take the decision which you like means consider you have decision I and decision j, I am just naming them as I and j, or alternatives which are, or the decisions which are there based on criterias, and if you take I with respect to j, you get a positive benefit, and you basically put them in the set known as the concordance set or positive ranking. And if you take the decision which is not beneficial, you basically formulate the discordant set, and then also you have an negative outranking, and combining them you basically find out which decision basically best suits you, considering the overall set of criteria which you have. So, with this I will continue the discussion, and if you remember also I mentioned that we will consider the outranking whether in the positive sense or in the negative sense to be of equal magnitude, in the sense that if I win 100 rupees or if I lose 100 rupees, my level of liking and disliking would be of the same magnitude. This is something to do with, in a way, the squared error loss function. And there are some reasons for that, because if you remember I did mention beginning of the this DADM2 lecture series that having a squared error loss is akin to considering the returns to be quadratic, the utility function to be quadratic and returns to be normally distributed, such that there is a 1-to-1 correspondence there. And we will try to follow that and slowly relax and take the assumption that asymmetric loss function, where unequal penalization of outranking in the positive sense and the negative sense can be considered, and we can model that also accordingly. So, this slide we have, this was the ending slide for the last class, which was the 25th class, but still I will continue discussing that. So, thus intuitively one start with a set A, where set A has A1, A2, so 1, 2, 3, 4 are the suffixes. So, A1, A2, A3 till AN, where the number small n is basically a number of alternatives or decisions which you have. So, thus each will basically have A1, small a1, small a2, small a3 corresponding to the fact that what is the weightages you are going to give to those alternatives based on the criteria. So, let me continue that, such that each ai, that is I is equal to 1, 2, 3, 4 till n, has L number of set of criteria. So, obviously A1 would be divided as, so if you have A1 from this, so A1 technically would be A11 till A1L for all the L number criteria. Similarly, AI would be AI1 till AI capital L, and you can basically formulate it accordingly, such that each AI I is equal to 1 to n has small l, L basically nomenclature being from 1 to capital L, number of criteria, and one accomplishes, one means the decision maker accomplishes his or her ranking based on the collective, the cumulative effect of all these different alternatives criteria on the ith alternative. So, we will combine them, try to basically find out what is the collective effect and basically take the decision. So, if I continue reading it, it says that one accomplishes his or her ranking based on the collective cumulative effect of these L criteria when comparing any two different alternatives. See for example, A I and A j, I not equal to j and I and j being equal to 1 to n, because if I and j are same, that means you are comparing two alternatives which are the same with respect to the criteria. So, obviously, they would not make much sense. So, it is almost equal to the concept that you are taking the principal diagonal for the HP, where the numbers you have assigned is 1. That means, it is difficult to take decision I with respect to I if I and j are the same. At the end of the comparison process, we end up with a best choice set, which is capital A1, where capital A1 would basically be a subset of that bold A would be the set of all the A's which you have considered. So, we will basically rank them according to ordered them, like A3 can be better than A4, A4 can be better than A10, A10 can be better than A1. So, based on the collective decision of the criteria. One advantage of the ELECTRE process on the method is the fact that the final result, which is A1, when presented to the decision maker, it is easy for him or her to take the final view rather than what he or she would have taken with A only. So, you basically give him or her the choice set based on the criteria, such that is easier for him or her to take the decision. So, as in that process, in case it is difficult for the person to judge the n number of alternatives in a rational method, considering n can be large. If you remember in the AHP method, I did mention that trying to basically find out the ranking process considering n is very large and you are going to do n C2 combinations may be confusing, because if you are trying to compare on the same criteria for all the alternatives time and again, like say for example, style, and you have basically 20 cars to compare, 20 C2. So, style when you are going to compare, obviously this concept of consistency will be violated, because then it becomes very difficult to make a rational choice. So, you want to basically choose alternatives in a rational manner, so as to choose the so called best set of elements amongst the n number of originally set which is already there. Now, how does the process work? In case if the ith alternative, now I am considering the alternatives not in the criteria. So, if the ith alternative A I outranks the jth alternative A j, then we say that A I is better than A j. Now, the question may come that if there is only one criteria, then it is very easy. I only consider one criteria, find out A I is better than A j and my job is finished. What if, say for example, if there are two criteria and I am considering the alternatives I and j, with respect to the first criteria A I is better than A j, and with respect to the second criteria A j is better than A I. So, how do we do that? I will come to that later. So, it means that the risk or loss, whatever one wants to say, risk or loss in the monetary sense, we will say that for A I is not as much as that A j. So, whenever we are saying that A I is better than A j, we are thinking from the loss perspective that the loss of A I is just equal to A j or is less. So, obviously, we like to take A I as the best alternative with respect to A j. So, we will say that and if I continue reading, it means that it means that the risk or loss, whatever we want to say, for A I is not as much as A j, or A I is as good as A j and not as worse as A j. So, whenever we are comparing, if say for example, there are two alternatives. So, say for example, A1 and A2, and the criteria are 2 in number, the first and the second. Consider on with respect to the first, A1 is better or just equal to, and in the case of the second criteria, A1 is just equal to A2. So, even if one of the criteria based on the one of the criteria A1 is better, so we will definitely take A1 and proceed. and that question that if they are conflicting criteria, how we do that. Now, how one decides the so called relative ranking between the alternatives E I and A j is a matter of prime importance to what, and we will basically consider that accordingly. It is also worthwhile to mention that here is where the collective accumulative effect of L number of criteria come into play, such that we are able to consider all of them at the same time or individually and find out the collective total effect of all the L number of criteria when we are trying to consider the alternative 1 and 2 or I and j. So, electro ranking system is non transitive, that means if say for example, A I is better than A j and A L is better than A k, we may not imply that, say for example, this should say it is there is one error. This should be changed. So, if A I, so what we actually mean is if A 1 is greater or better, not greater, better than A 2, 1 and 2 are just arbitrarily, A 2 is better than A 3, it does not imply that A 1 is better than A 3. So, you have to basically consider that when considering the method of electro process. I will change that accordingly. So, obviously, it means that 1 is better than 2, 2 is better than 3, it does not obviously always mean that 1 is better than 3. In ELECTRE, one uses the concept of concordance and discordance set or concept, which is a sort of level of liking and disliking. Concordance means I like, so hence I give positive weights or positive points. Discordance set is basically I dislike, I means the decision maker dislikes, so hence he gives a level of points which gives the level of discordance or disliking. So, which one has to use this concordance and discordance set has to one has to use based on the criteria between any two alternatives. So, it does not mean that if I give a concordance score between two alternatives, it does not mean that I am not going to assign a discordance score. So, if you remember, I did mention that if A1 and A2 are there alternatives and I like A1 or the decision maker likes A1. So, in the case A1 is chosen, then obviously there is a positive point. But in case, say for example, due to some situation you are forced to choose A2, then in that case you will basically give a level of disliking such that you basically make a very rational decision that liking and disliking would be given as positive and negative points. So, that collectively we are able to balance that and take a rational decision. So, if we say that we like A I with respect to A j, when one chooses A I in place of A j, then one assigns some score or points to the quantify this level of liking, and this is known as the concordance set or level. On the same basis, as I said, if due to some reason one is forced to choose A I with respect to A j, it is just the reverse, not to choose A I with respect to A j, then the level of disliking is objectively stated using the concept of discordance. Now, consider this, there may be some liking and disliking, and this liking comes out more prominent. So, hence it will become a concordance set, and if the disliking comes out to be more important, then it will be a discordance set, and we will try to take a collective decision based on both of them. To deal with the outranking relationship by using pairwise comparison, that means I am trying to analyze A I with A j among alternatives. So, such that under each of the criteria we are able to do it separately. So, say for example, for the L is equal to 1, we rank them A 1 and A 2. For L is equal to 2, we then rank them between A 1 and A 2 and continue doing that such that we take a collective score based on the concordance and the discordant concept. The outranking between two alternatives A I and A j denoted by A I is better than A j, which generally means even if the ith alternative is not dominating the jth one, yet the decision maker can choose the ith one, because in that case the effect which the person has on trying to choose A I is better than A j. So, say for example, if I am considering that the AI and AGs are ranked in such a way for the criteria, I am not getting any benefit for choosing any of the alternatives, the first and second, based on the fact, say for example, I am considering the criteria. But still I may be interested to take AI with respect to AJ, in spite of the fact that the alternatives which are there, or say for example, the criteria which are there are not helping, but yet I will basically assign some concordance set or concordant points such that in the long run when I take a decision of AI with respect to AJ, I will get a positive benefit. Alternatives are dominated if there is another alternative which excels them in one or more criteria and equals in the remaining criteria. So, say for example, I have A, I and A j, these are the alternatives, and L is equal to, say for example, 1, 2, 3. Now, consider with respect to L is equal to 1, A I is greater than A j. With respect to 2, A I is equally disposed with A j, and respect to 3, A I is equally disposed with respect to A j, then obviously there is one concordance point, hence we will be interested to take A I, because for this L is equal to 2 and 3, they are equally disposed in the sense the alternatives. We consider pairwise comparison of alternatives under each criteria by using some matching index like monetary value, and we will give that function as G I A j. That means, for each of this criteria we take the comparison of the alternatives, compare them and assign scores accordingly, positive or negative, whatever it is. So, one should specify the threshold. So, what is the difference of the threshold? So, if I take a functional mapping or the difference of the scores between A I and A j for the criteria 1, criteria 2, criteria 3. So, obviously, if the difference is almost negligible, so then in that case I am indifferent. In case if they are not, so obviously I will be tempted to take the decision 1 with respect to 2, that means alternative I with respect to j. Hence, the threshold which is given by the functional form of G I A j minus G I A k, it will depend on the decision maker's choice. The concept of utility function would be very important here, and we will consider that later on. The decision maker assigns weights or important factors to the criteria, and that is done in order to express one preference to show the relative importance of one alternative with respect to the other and take decision accordingly. This also comes from the fact of outranking, liking and disliking, comes from the fact that the utility function or net value concept of any decision maker or making process is important driving force or factor for the choices, and their ranking for any particular decision maker would also always hold, because the decision maker is trying to utilize the concept of ranking of liking and disliking in such a sense that he or she will give some positive and negative points to this outranking method of liking and disliking and then take the decision. This method is convenient when there are few criteria and a large number of alternatives. So, trying to compare the alternatives with few criteria, this will definitely be advised, because if you remember same thing was said of the HP, because if the number of different comparison increases, then there is a chance that the rationality or criticality index may be violated. So, we will basically consider this algorithm in a very simple step, like step 1, 2, 3, 4, and then also solve a very simple theoretical problem. So, what for the step 1 is normalize the decision matrix, and what we do. So, we have a set x. So, x is basically the scores which have been assigned with respect to some monetary value. So, we will convert the entries in the decision matrix called the scaled normalized values, which has no dimension. So, thus we will consider that the matrix A which we have, where the cells are A1, or if you consider along the rows, it is A11, A12, A13, A14, so on and so forth. So, we will normalize them considering either through the row or through the column. This is the important fact which I had mentioned time and again in HP, that you normalize using the utility function 0.1, and you also ensure the normalization can be done along the row or along the column, but remember the fact after normalization the sum should be equal to 1, such that you have basically have the relative ranking system in such a way that it is better for you to compare. So, here we take x I j as the ratio of a I j divided by the square root of the sum of the squares of the a I j's corresponding to the sum for the row or the column. So, please remember the normalization depends on the utility function. So, the square concept which you have used has something to do with the utility function which is quadratic, which means that the returns which you are going to take is normal. So, this is just a simplistic one, it can be logarithmic, it can be power utility function, it can be Hara function, whatever you want to take. But remember that as I had mentioned that in AHP, once you basically decide on the utility function for the decision maker, do not change the utility function for the decision maker when you are trying to compare different type of alternatives or different type of criteria based for the same alternatives. Thus, when the normalized vector is obtained from A, so you have x as the matrix. It can be a vector depending on how many alternatives and this criteria if you have. So, x is basically the matrix which has the cell values. If we consider the topmost row, it will be x 11, x 12, so on and so forth till x 1n, and the last row would be x m1 till x mn. And remember what is m and n are basically the numbers of decisions on alternatives and the number of criteria. Here m, as I just mentioned, here m, which is the third bullet point it mentions, here m is the number of alternatives shown along the rows, and n is the number of criteria which is basically shown along the columns. The normalization which you do or which the decision maker does implicitly depends on the utility or what he or she or you think each of the individual criteria is giving or contributing to each alternative on an individual basis. So, once you normalize the scores which you get, say for example, the score for one of the criteria for one of the alternatives is 0.12, which means the total weightages or the overall effect of that criteria on that alternative when you are trying to compare the alternatives would be of 12% worth on a scale of 100. Now, obviously, the question may arise that what if the weightages of this criteria changes for a per alternative. So, like say for example, for the ith one I give a weight of 12% for the alternatives which you are going to consider. So, it will be say for example, A1, A2 are the alternatives and L is the criteria. So, say for example, the normalized weight is 12%. So, we will continue considering 12% for A2 also, but if the question arises what if we take 25% here and 12% here, that concept we are not going to consider in our problem, because we will consider there is a changing weightages you are going to assign to the criteria, but we are not going to consider that. So, the last point mentions the normalization which you do implicitly depends on the utility or what you think each individual criteria is given or contributing to each alternative on an individual basis. So, consider this. So, I have the matrix A, which is the so called non-normalized matrix, the points which are given without any units as per the figure with the values which are giving along the rows is 2 1 2 3 4 1 1 3 2. Here m is 3, n is 3, it can be m and n can be different also, but I am taking a simplistic problem. So, once you normalize using the quadratic concept, x becomes the first cell is the values which I will take, and if I am doing it along the column. So, it will be 2. So, this one which is coming, and this will be the sum of the squares of these. So, square root of 2 square plus 3 square plus 1 square. So, this value which you see is here. Now, say for example, when I do it for the second one, which is 3. So, 3 and in that case you have 2 square plus 3 square plus 1 square, this value is here. Similarly, so this one was considered, this one was considered, let I consider this. So, it becomes 1 divided by 2 square plus 1 square plus 2 square, the value is here. This is the one, this is the one. I am just marking it with the color scheme, so it is easier for you to understand where and how the calculations have been done. So, you can find it accordingly. So, you normalize the decision matrix. Now, we multiply each of the column of the previous matrix x which you have observed by the associated weights you are going to assign and the level of importance you are going to assign to the decision. So, consider the weights are given as W 1 for the first until W n for the second, for the last one, and here if you remember I mentioned just a few minutes back that if I consider the alternatives, and we are also going to consider the fact which is a simplistic assumption that the weights which are there for the alternatives for any of the criteria would be of equal weightages. So, if it is 12%, it remains 12%, if it is 25%, it remains 25%, we are not going to change that, and that is why the weights are there. So, W 1 remains at W 1 for all the things. Remember one thing, the first row, the first cell value is W 1, others are 0, that is why the weights are same. For the second row, the second cell which is 2 comma 2 is W 2, rest values are 0. For the third row, the third cell which is 3 comma 3 is W 3, rest are 0. So, that is why I kept repeating it time and again, the weights remain as it is, and it should also be remembered that you have normalized. So, the sum of the weights should be 1. So, once you multiply the normalized x with the weights, you will get the total weighted sum of the alternatives and the criteria based on which you will proceed for the next step. So, with this I will close this first lecture for the 6th week, which is the 26th lecture, and I will continue trying to solve the problem with all the steps which we will consider a very simple algorithm, and try to also analyze that what if the ranking positive and negative, concordance and discordance are not of equal importance, then how you will do, we will consider that later. First, let us consider they are of equal importance, that positive weights and negative weights would be same. Weights I am using in the very simplistic sense, not from the mathematical point of view. So, with this I will end this class, and thank you very much for your attention. Have a nice day.